So moving on with factoring trinomials, a lot of the skills that we've been working on are going to carry over, but there is a slight difference between what we've been doing and what we're going to start doing. If you haven't noticed, all of the trinomials that I've asked you to factor up until this point have looked like this. The whole multiply to, add to kind of thought process is going to carry over 100%. However, what we've not had to worry about were polynomials that had a coefficient out front. Because these had a 1 x squared or 1 whatever your variable was, we could kind of just overlook it and just focus on these two guys here at the end. The ones that we're doing today, you can't do that. You have to spend a little bit more time kind of thinking about what's going on here. So it's really easy to incorporate that number out front. So instead of trying to find numbers that multiply to 8 and add to 14, I'm going to multiply the first and last number here. So 3 times 8 is 24. So what I'm looking for are numbers that multiply to 24 but still add to 14. So that's what I mean, like the thought process is going to carry over 100%. It's just that you've got to incorporate that first number. Okay, so numbers that multiply to 24. Again, I'm encouraging you, if you're not doing this, if you're struggling, make the list of all of your pairs. It only takes a second to get them all kind of exhausted. There's 4 pairs of numbers. I want the pair that adds up to 14. Okay, there's only one of them. So when I split this guy, and it doesn't matter whether 2 or 12 comes first, I'm going to split it into 3p squared. I'm going to go with the 2 first. Okay, so once you get that 14 split, it's factor by grouping, the same way that we've been doing it. Just kind of complete my chart here. So I chose 2 and 12 because they add up to 14. So the first half here, what might happen on these is you have more than just a variable in common. You might be able to also divide out a number. Okay, the ones that we've done so far, because it started out with just a p squared or x squared or whatever, there was no number that you could divide out of there. These have the possibility to have a number that you can divide out. So if I had put the 12 here, I would be able to do that. Actually, I'm going to switch this just to kind of illustrate what's going on there. So instead of, let's make that a 2 instead of a 12. All right, so now when I go to divide out, 3 and 12 are both divisible by 3. So I'm going to be able to divide that out as well as my variable. And that'll leave me with a single p plus 4. If I had switched it and put the 2 first, they wouldn't have a number to divide out. Now you might think, well, that totally throws everything off. It doesn't, because we have a whole second half of the problem that would make up for not dividing out of the first one. 2 and 8 are both divisible by 2. So that's going to leave me p plus 4. Okay, same as it was all last week. Those sets of parentheses have to match. So I've got one factor that's p plus 4. My other factor is 3p plus 2. And you can write those in either order. It does not matter. Okay, same thing. You're going to have to multiply that first number and the last number. So I'm looking at 2 times negative 5. I need numbers that add to negative 10. Okay, so these guys are my add to number now. I want them to add to negative 10 and still multiply to negative 9. So again, I'm writing out all my pairs, 1 times 10, 2 times 5, and that's it. There's no other numbers that multiply to 10. So the only way I'm going to be able to kind of engineer that negative 9 is here with the 1 and the 10. So I'm going to split that 9 into negative 10v plus 1v. Okay, cut it in half. Excuse me. Cut it in half. So this is divisible by 2v. That leaves v minus 5. Now the second half is already v minus 5, but I need that greatest common factor out front to piece together my answer. You can always divide out a 1. So my factored answers are 2v plus 1, v minus 5. Okay, I'm going to do one more. This takes practice. You can't be 1,000% lazy and do these. You have to take using photomath, which I know some of you are doing. I'm not stupid. It's giving you answers. It's giving you answers that aren't things that we've talked about. So I'm not dumb. I'm seeing that. You keep using it. I'll bite you. It'll bite you in the butt later on. All right, last one. This is a little bit bigger. So I'm looking for numbers that multiply, this time to 90, and add to negative 23. So let's see, 6 and 15 gave me 90. So I'm going to write out all my numbers that multiply to 90. That seems like a lot. It'll be pretty evident here in just a second what's what. 4 doesn't go into 90. 5 does. What is that? I don't know what that is off the top of my head. Who divides 90 by 5? 18. 90 divided by 6 is 15. 7 doesn't work. 8 doesn't work. And 9 does. And then it starts to repeat. So that's my whole list. It took me 30 seconds, if that, to come up with the entire list. I need a pair of numbers that are going to add to negative 23. Well, those won't. Those won't. Those won't. Those won't. Look at that, 5 and 18. Okay? It takes a little bit of time. If you're not real good with your multiplication table, take a second on the calculator and divide. All right, so I'm going to split this guy. Minus 5a minus 18a plus 15. All right, the first half is divisible by a only. So 6a minus 5. Second half starts out negative, so I have to divide out a negative. I'm going to divide by negative 3. Come on, pen. 6a minus 5. It's like a third grader wrote that. Okay, so my factored pieces are 6a minus 5. A minus 3.